So that's one way we can say if something's no good. We can look at if it's biased or not. But we've still got theta 1 hat and theta hat 2, which are unbiased. So why don't we use them instead of using a sample mean? What's wrong with them? Well, if we look again at the box plots, the other thing that you'll notice is that the x bar, the fourth one, it's much closer to the true mean. Okay, true means here, these values are all much tighter around the true mean, whereas these ones are all over the place. There's a lot more variation there. So when thinking about if an estimate is good or not, instead of just looking at the expected value, looking at if it's biased, we also look at its efficiency. We look at its variance. So what's the variance of theta hat 1? Well, it's the variance of x1, that's sigma squared. What's the variance of theta hat 2? Well, it's the variance of an average of two values, and it ends up being sigma squared on 2. So that tells us that theta hat 2 is better than theta hat 1. It's got half the variance. But it's nowhere near as good as averaging all 50 values now, is it? Remember, the variance of x bar is sigma squared on n. For 50 observations, we're talking sigma squared on 50. That's 25 times less than the variance of theta hat 2. So this one is like, it's got heaps less variance than theta hat 2, which has got slightly less variance than theta hat 1. We could see that here we go. Variance, what's the variance of theta hat 1, of theta 1? What's the variance of theta 2? Okay, 6.5 for the first one and 2.9 for the second one. So the variance is much smaller for theta 2 than for theta hat 2 than it is for theta hat 1, but it's like heaps bigger than what we got for theta hat for x bar. Okay, for x bar it was much lower again, like 0.09. It's like heaps less the variance than these other ones. So the winning estimator out of these ones is x bar, and in fact, in most practical situations, there isn't a better estimator than x bar. So yeah, for most of the time, if you're interested in a mean mu, you would use x bar, and that's what we'll do in this course because it's unbiased and it's more efficient than other estimators that are out there. When we're talking about bias and efficiency, you can think of it as like shooting at a target. So the top left diagram. Top left part of the diagram, we've got something that's missing the target. It's getting close to each other all the time, so there's low variance. The variance is low, it's fairly efficient for whatever it's estimating, but it's not estimating the right thing, it's biased. So the top right, we have something which is unbiased, it's aiming at the target, but it's kind of all over the place. It's got a fair bit of variance, it's not very efficient. The bottom left, missing the target with high variance, so it's not very efficient and it's biased. And finally, we've got the ideal is to have something which is unbiased and quite efficient. And yeah, x bar, it's hard to beat x bar in terms of trying to find something which is on target and sort of quite efficient in trying to estimate that.